This is a tutorial that will discuss follicle-stimulating hormone and luteinizing hormone, which stimulates the production of androgens. This particular tutorial will focus on these two hormones in light of the male, and these hormones are generated by the anterior pituitary. The functions of follicle-stimulating hormone, which will be abbreviated as FSH, and luteinizing hormone, which will be abbreviated as LH, include androgen production as well as gamete production. When considering my feedback loop, I have to consider that gonadotropin-releasing hormone is ultimately secreted by the hypothalamus, which is going to have a direct effect on the pituitary gland. So this is to illustrate the bottom of the brain in the hypothalamus, and this is my pituitary gland. This is the anterior portion and the posterior portion. As I mentioned just before, I drew my pituitary and hypothalamus. Gonadotropin-releasing hormone is secreted by the hypothalamus. The hypothalamus then sends this hormone down through a portal of blood vessels to the anterior pituitary, where follicle-stimulating hormone and luteinizing hormone are both released. These hormones target the testes, and the testes responds via two things. Remember, the first function is androgen production, so we're going to secrete testosterone. And testosterone is the male androgen. And we're also going to see an increase in gametes. In the male, this is the production of sperm. Now, it's important to note that sperm production is partially dependent upon testosterone function, so the testosterone itself will also cause the formation of gametes. Interestingly enough, there is a paracrine signal in the testes. Now, a paracrine signal is a hormone signal that has a direct effect on the tissue from which it was released. And it turns out that testosterone itself is the paracrine signal back on the testes. So as testosterone amounts elevate, the testes detect increasing amounts of testosterone, and the testes will then respond by producing another hormone, which is called inhibin. When inhibin is released by the testes, it is going to circulate in the bloodstream until cells in the hypothalamus detect its release and secrete gonadotropin inhibiting hormone. For our intents and purposes, we will be considering whether these hormones are protein or lipid based, as this indicates how long of an effect ultimately they will have. So the androgens, like testosterone, are lipid-based hormones, and they tend to have long-term effects. Whereas inhibin is a protein and is rapidly broken down. So we can shortly turn off the secretion of follicle-stimulating hormone and luteinizing hormone, and when inhibin levels fall, then the gonadotropin-releasing hormone will again start to be produced. Pathologies, of course, do occur when there are alternate amounts of circulating hormone. In the case of follicle-stimulating hormone and luteinizing hormone, when there is a hyposecretion by the anterior pituitary, we tend to see more feminine-like characteristics. Difficulty growing the hair that's associated with secondary sexual characteristics, such as a thinning beard or mustache. And lastly, a reduced sperm count. This completes the tutorial on follicle-stimulating hormone and luteinizing hormones effects in the male.